Exercise 6.3. Question number 2. In the given figure, triangle ODC is similar to triangle OBA and OBC is 125 degrees and angle CDO is equal to 70 degrees. We are supposed to find out angle DOC, angle DCO and angle OAB respectively, right? Okay, how do I do it? For this, look at the diagram carefully. You're given two similar triangles, right? What are the two similar triangles which you're given? This is one of the triangle, that is triangle ODC, and this is triangle BO and C, right? Okay, now you're given that the angle BOC is equal to 125 and this angle is 70. Okay, now look at this line OB. Now this line is a straight line and the angle BOC and angle COD are making a linear pair. So the sum of these two angles is equal to 180, right? So in order to get this angle, what should I do? I should subtract 125 from 180 and we will get the answer as 55, right? So we have got angle DOC is equal to 180 minus 125, which is equal to 55 degrees. Okay. Now look at the triangle, that is DOC, this triangle, right? Now in this triangle, we know that one of the angles CDO, that is this orange angle, is given as 70 and we have just now calculated that this angle, that is angle DOC, is equal to 55 degrees, right? Okay, now we know two angles in a triangle, so we can use the angle sum property to get the third angle. So we know that angle DCO is equal to 70 plus 55, that is equal to 180. So from this, if you calculate the value of angle DCO, we will get again that is equal to 55. So we got the angle DCO. This is this angle. We got it as that is 55 degrees, and we already got the angle DOC, that is also 55. Now we know the two triangles are similar, which is given to us, so the corresponding angles should be equal, right? So angle AOB also will be equal to 55 degrees and we got all the angles which is required. In the question number 3, we have got the diagonal AC and BD of trapezium ABCD with AB parallel to DC intersect each other at point O. As given in the diagram, we can see that AB is parallel to DC and they are intersecting each other at O. Using similarity criterion for two triangles, you are supposed to show that OA by OC is equal to OB by OD, right? Okay, how to do it? Let's see that. Write the proof and statement. You consider the triangle OCD and OA and B. There are two triangles which are given here. And you also know that this line AB and CD are parallel to each other. So therefore, we will have angle 1 and angle 3 are equal, and similarly angle 2 and 4 are also equal because they are alternate angles, because you can see that AB and CD are given as parallel and AC is one of the transversal and BD is another transversal. So alternate angles are equal. Okay, now you can also see that angle DOC is equal to angle BOA. See, they are dancing slightly. So these two are equal. Why? You know that they are vertically opposite angles. Now in the two triangles, that is triangle OCD and OAB, these two triangles, you can see that all the corresponding angles are equal. So by AAA similarity, triangle OCD and OAB will be similar to each other, right? Now you have proved that the two triangles are similar. And you know that if two triangles are similar, then the corresponding sides are proportional, right? So which makes this OC by OA is equal to OD by OB. Then you can write the reciprocal is also equal, just reciprocate it and get whatever you are supposed to prove. That means OA by OC is equal to OB by OD, and you have proved it. Question number 4. In the given figure, you are given that QR by QS is equal to QT by PR and angle 1 is equal to angle 2. We are supposed to prove that triangle PQS is similar to triangle TQR. What is given to you? QR by QS is equal to QT by PR, and also we are given that angle 1 is equal to angle 2. We are supposed to prove that triangle PQS and TQR are similar to each other. Let us write what is given to you. So it is given that QR by QS is equal to QT by PR and angle 1 is equal to angle 2. Right, to prove the two triangles PQS is similar to triangle TQR. Right, let's do it. Write the statement as well as the reason. And first consider triangle PQ and R. Since angle 1 is equal to angle 2, which is given, it makes the triangle as isosceles triangle. And what do you know about the isosceles triangle? Yes, if two angles of a triangle are equal, that is isosceles triangle, the opposite sides also will be equal, which will make this PR equal to PQ, right? Okay, now we know that PR and PQ are equal. So, what is given to us? QR by QS. QR by QS is equal to QT by PR, but PR is equal to what? PR can be replaced by PQ, right? Okay, this is PQ. Huh? So, replace this PR by PQ and you have got the next equation here. Right, QS by QR is equal to PQ by QT, right? And when you consider the triangle PQS and TQR, you have this angle 1 which is common to both the triangles, right? What is the name of this triangle? In the triangle PQS, you will write this as angle PQS, and TQR, you will write it as angle TQR, right? Okay, that means it is the angle 1. And also just now you have proved that the sides are proportional. So, by using the SAS similarity criterion, these two triangles will be similar, and this was what supposed to be proved, right? S and T are the points on the side PR and QR of triangle PQR such that angle P is equal to angle RTS, and we are supposed to show that angle RPQ is similar to triangle RTS. Look at the figure here. You can see that S and T are the points on the sides PR and QR of triangle P, Q and R, and you're also given that angle P is equal to angle RTS. The blue angles are equal. You are supposed to show that triangle RPQ and RTS are similar to each other. First, you draw a construction that draw a triangle PQR and S and T, since they are on the sides PR and RQ respectively, join this line, right? Okay. Now, to write the proof and statement, consider the triangle RPQ and RTS. See, first I have taken RPQ this way and RTS the other way. Right, I have taken the corresponding angles to be equal. You are already given that angle RPQ, that is this blue angle, and angle RTS are equal to each other. Right, and you have got this angle, that is PRQ and TRS, the green angle, is common to both the triangles, right? So they have to be equal. So the two triangles, triangle RPQ and RTS, are similar by AA similarity criterion, and this was supposed to be proved. In the figure, it is given that triangle ABE is congruent to triangle ACD, and show that triangle ADE is similar to triangle AB and C. How do I prove it? Let us write whatever it is given. Triangle ABE is congruent to triangle ACD, so corresponding part should be equal, and we are supposed to prove that angle ADE is similar to triangle ABC. So to prove it, let us first consider the triangle ABE and triangle ACD, ABE and triangle ACD. We know that the corresponding parts are equal, so AB should be equal to AC, right? And we also know that the side AE and AD are also equal by CPCT. Therefore, we know that AB by AC is equal to 1 and AD by AE is also equal to 1. Each is equal to 1. So, AB by AC should be equal to AD by AE, right? Okay, now let us consider the triangle ADE and triangle ABC. What you have? You're already given that AD by AE is equal to AB by AC. Just slightly make a change by bringing AB down and AE up. So you will have this AD by AB is equal to AE by AC, right? Okay, and you also have the angle DAE and angle BAC, same angle, that is this angle A, right? So being common angle, it has to be equal. So the triangle ADE and triangle ABC are similar by using what criterion? Side angle, side criterion. And this was what we are supposed to prove. Question number 7. In the given figure, altitude AD and CE of triangle, this is ABC, intersect each other at P. You are supposed to show that triangle AEP is similar to triangle CD and P. These two triangles are similar. The first question, right? Now, what you can see here is that two angles of these two triangles are 90 degrees. Right, because we know that AD and CE are perpendicular to each other. So each of these angles is 90 degrees, and also that angle APE, this is angle APE, and triangle CPD both are equal, meaning what? It is vertically opposite angle. The red two angles are vertically opposite angles. So in these two triangles we have got 190 and one vertically opposite angles. So these two triangles are similar by AA similarity criterion. So we have proved that triangle AEP and triangle CDP are similar to each other. Similarly, let us go to the next question, proving that ABD, the triangle ABD and CBE are also similar to each other. In this you can see again that two angles, angle AD and B, ADB, this angle, and CEB, these two angles are 90 degrees. So they have to be equal. Right, and we have got angle ABD, this is this angle, blue angle, and angle CB and E, this is the same angle, the blue one. So the naming is different because the triangle has become different. So these two triangles again will be similar by AA criterion. One is 90 and other one, the blue angles are equal. Right, so that makes triangle ABD and triangle CBE similar to each other. Now we have got the third part and the fourth part which is left out here. We'll go to the next page and do it. Now here we have got triangle AEP, AEP and triangle ADB. This is triangle ADB. Are they also similar? Let us see. You have got this AEP angle is equal to angle ADB, which is each equal to how much? That is equal to 90 degrees. Okay. Now angle PAE, PAE and angle DAB, they are the same angles, right? The yellow one. They are common to both the triangles. So, again these two triangles are similar by using AA similarity criterion. The fourth part, in triangle PDC, this triangle and triangle BEC. Again you can see that you have got angle PDC and the angle BE and C, these two are 90 degrees, so they have to be equal. And we have got angle PCD, this angle, right? And angle BCE, again this is the same angle, so these two are equal. So again these two triangles will be similar by what? By AAA similarity criterion, right? So we have proved all the four cases that the triangles are similar to each other. E is a point of the side AD produced of a parallelogram ABCD and BE intersects CD and F. Show that triangle ABE is similar to triangle CFB. You are given that E is a point on the side AD of parallelogram ABCD and BE intersects CD and F. You can see in the diagram. To prove that triangle ABE is similar to triangle CFB. Right, you're given a parallelogram ABCD as you can see, and you're supposed to prove that triangle ABE is similar to triangle CFB, right? For this, let us consider triangle AB and triangle CFB. You are given that angle A will be equal to angle C. Why? ABCD is a parallelogram and opposite angles of a parallelogram are equal, and angle AEB and CBF are also equal, being alternate angles, because AD and this side BC are parallel, so AE and BC also will be parallel, and the green angles are alternate angles, as you can see, so they will be equal. So these two triangles are similar by AA criterion. So the two triangles are similar to each other, hence proved. Let us do the question number 9. In the following figure, triangle ABC and triangle AMP are two right angles, right angled at B and M respectively. We are supposed to show that triangle ABC and triangle AMP are similar to each other, and also CA by PA is equal to BC by MP, right? So for this, write the given. Given is triangle ABC and triangle AMP, two right triangles, right angled at B and M. We are supposed to prove that triangle ABC and triangle AMP are similar to each other, and also the sides are proportional. Let's do it now. When you consider triangle ABC and triangle AMP, you are given that the angle ABC and angle AMP are each equal to 90 degrees given now, and you have got in both the triangles this angle A is common. So this makes triangle ABC and triangle AMP similar to each other by AA similarity criterion, right? Now we know that if two triangles are similar, the sides will be proportionate, right? So if you consider triangle ABC, the side which is opposite to, that is 90 degrees, it is CA. And same thing if you consider in this triangle AMP, you have got the side which is opposite to 90 degrees is what? It is equal to PA. So put the values. And if in the triangle ABC, if you want to consider BC, BC is opposite to A, right? And similarly in this triangle, that is AMP, the side which is opposite to A is MP. So the corresponding sides of similar triangles are proportional, we know. So we have proved it. Let us do the question number 10 now, and in this we are given that CD and GH are the bisectors of angle ACB, that is angle C, and angle G respectively, and D and H lies on the side AB and FE respectively of triangle ABC and triangle EFG. If we already are given that triangle ABC and triangle FEG are similar to each other, we are supposed to show that CD by GH is equal to AC by FG. Triangle DCB is similar to triangle HGE, and triangle DCA is similar to triangle HGF, right? You're supposed to prove this. How do I do it? Look at the diagram here. And since we are already given that the triangle ABC and FAG is similar to each other, therefore we will have angle A is equal to angle F, angle B is equal to angle E, and you also will have the angle ACB, that is angle C, and angle FGE equal to each other. That means the yellow angle is equal to yellow angle, because we have written A first here and F first here, so they should be equal. The green angles B and E are equal, and the blue angles, that is angle C and angle G, are also equal, because it is given the two triangles are similar to each other. They are also given that the line CD is the angle bisector of the angle C, right? So CD divides the angle C into two equal parts. Similarly, you're also given that this GH is the bisector of angle G. That means this line also bisects the angle G into two equal parts, right? So that will make angle ACD equal to angle FGH, right? Okay, if two angles are equal, the half part of it also will be equal. So similarly, we will also have the angle DCB, that this side angle, and angle HGE, they also will be equal. right? Okay, now when you want to solve the question which is given above, we are supposed to prove that triangle ACD, that is this triangle, and triangle FGH are similar to each other. Consider them. You have got the two yellow angles equal to each other, which is given to us as the triangles are similar, and angle ACD, this is angle ACD, right? And angle FGH, the half of angle C, they are also equal. So the two triangles are similar by AA similarity criterion. Okay, done. Now, if the two triangles are similar, you will also have the sides proportional to each other. The side opposite to yellow angle in this side is CD, and in this triangle, the side which is opposite to yellow angle is equal to HG, and that is proportionate to AC by FG, right? We have proved two things. Now, the third triangle in triangle DCB and triangle HGE, we know that the green angles, angle DCB, that is half of angle C, and angle HGE, that is half of angle G, are equal, which we have proved above. Angle B is equal to angle E, the green angles are already equal, right? And therefore, these two triangles are also similar by AA similarity criterion. So, we have proved what we wanted. Question number 11. In the following figure, A is a point on the side CB produced of an isosceles triangle ABC with AB equal to AC, and if AD is perpendicular to BC and EF is perpendicular to AC, prove that triangle ABD is similar to triangle EC and F, right? What is given to you? You are given a triangle that is A, B and C, as you can see in the diagram, right? Okay, in that you're given that AB and AC are equal to each other, AD is perpendicular to BC and EF is perpendicular to AC, right? You're given that triangle ABC is a isosceles triangle, right? AB is equal to AC, that is also given. So, which makes the angle B equal to angle C. The yellow angles are equal, right? According to isosceles triangle property, if the two sides of a triangle are equal, the opposite angles also will be equal, right? Okay. Now, consider the triangle ABD and the triangle EC and F. What you can see is angle ADB is equal to 90 degrees and angle EFC is also equal to 90 degrees. Say they both are equal. Hello, those red angles. Now you have got angle B is equal to angle C. The yellow angles are equal, right? So these two triangles will be similar by using the AA similarity criterion, and that was what's supposed to be proved. Let us do the question number 12 again. In the question number 12, AB and BC and the median AD of triangle ABC are respectively proportional to the side PQ, QR in the median PM of triangle PQR. We are supposed to show that triangle ABC and triangle PQR are similar to each other, right? We are given the two triangles ABC and PQR, AD and PM are medians respectively. Also that AB by PQ is equal to BC by QR and that is equal to AD by PM. Right. We are supposed to prove that the triangle ABC and PQR are similar to each other. So for that, let me consider what is given. It's given that AB by PQ is equal to BC by QR is equal to AD by PM. Right. Now, can we write it this way? Any problem? No. AB by PQ, instead of BC by QR, I'll write it as half BC by QR and that is equal to AD by PM. Now, this is not going to change the proportionality because I have multiplied half both to numerator as well as denominator. Right. Okay, now what is half of BC? Since AD is the median, half of BC is actually BD and half of QR is actually QM. Put the values. What do I get? The two triangles ABD and triangle PQM will now become similar to each other by SSS similarity criterion. So, what will happen now? The angle B and angle Q will become equal because the two triangles, if they are similar, then the corresponding angles will be equal. So, angle B and angle Q will be equal to each other. Now what you do is consider the whole of triangle ABC and triangle PQR. What you know here is we are given that AB by PQ is equal to BC by QR, right? Okay, and we have just now proved by equation 1 that angle B and angle Q are equal to each other. Now therefore what happens is triangle ABC is now becomes similar to triangle PQR, and that was what we were supposed to prove. P is any point on the side BC of triangle ABC such that angle ADC is equal to angle BAC. We are supposed to show that CA square is equal to CB into CD. Now what is given? D is any point on BC of the triangle ABC such that the blue angle ADC is equal to angle BAC, right? To prove that CA square is equal to CB into CD. Let us prove it. Consider the triangle ADC, the small triangle, and triangle BAC. Now it is given that angle ADC is equal to angle BAC, the blue angles, and the yellow angle, angle ACD in the small triangle is same as that of angle BCA, the yellow angle, which is common to both the triangles, right? So the two triangles, triangle ADC is similar to triangle BAC by AA similarity criterion. Therefore, we know that the corresponding side of similar triangles are in proportion. So, we will have side CP by CA is equal to side CA divided by CD. Cross multiply, you get the required answer. CA square is equal to CB into CD. Hence proved. Question number 14. Side AB and AC and the median AD of triangle ABC are respectively proportional to side PQ, PR and the median PN of another triangle PQR. We are supposed to show that triangle ABC is similar to triangle PQ and R. What is given? We are given triangle ABC and triangle PQR in which AB by PQ is equal to AC by PR, and that is also equal to AD by PM respectively. That is given to you. We are supposed to prove that triangle ABC and triangle PQR are similar to each other. So for this, let us make a small construction in which we have to produce this AD to E such that AD is equal to D, and also PM is extended to N such that PM is equal to PN, right? Okay. Now the proof. In the proof, we have got triangle ABD and triangle EC and D. The two triangles here, if you consider, we will have this BD equal to DC. Why? Because AD is the median and median divides the line on which it is drawn into two equal parts. AD is equal to D by construction, right? Okay, and also we have got the angle ADB is equal to angle CDE, these two angles, because they are vertically opposite angles, right? Okay, therefore the two triangles, triangle ABD and triangle DEC are congruent, exactly equal by SAS congruency theorem. So what you have here? AB side is equal to side AZB CPCT, corresponding parts of congruent triangles, right? Similarly, now you have to consider the triangle PQM and triangle NRM, right? For this, you already have this QM and M are equal to each other because we have got this PM as the median, right? Okay, now what about this PM and MN? They are also equal by construction. You have drawn it, and also you have got the angle PMQ is equal to angle RMN being vertically opposite angles. So again the two triangles will be congruent to each other. Triangle PQM is congruent to triangle NRM by SAS congruency, and by CPCT you will also have this PQ and NR equal to each other by CPCT, right? Now we have got side AB by PQ is equal to side AC by PR, and that is also equal to AD by PM. But just now we have proved that the side AB is equal to EC. So instead of AB, write EC, and instead of PQ, you can write NR. Just write this. So now what you have got? AC by RN is equal to AC by PR is equal to AD by PM, right? Okay. Now, if instead of AD by PM, can I write 2 times of AD by 2 times of PM. You're multiplying 2 to both numerator as well as denominator. But what is this 2 times of AD? It is equal to AE. And what is 2 times of PM? It is equal to PN. So substitute this value and then we will have the triangle AEC similar to triangle PNR by SSS similarity. The three sides are proportionate to each other, right? Okay. So therefore you will have this angle 1 is equal to angle 2, right? And similar triangles, the corresponding angles are equal, right? Okay. Now what you have to do is, we can also similarly prove that the angle 3 and angle 4 are equal to each other. Now we have got two relation number 3 and relation number 4. Add the two angles, angle 1 plus angle 3 and angle 2 plus angle 4. But what is angle 1 plus 3? That is equal to angle A. And what is angle 4 plus 2? It is equal to angle P. Right. Okay. Then in triangle ABC and PQR, we have got angle A is equal to angle P and the side AB by PQ is equal to AC by PR. That means the two sides are proportionate and included angles are equal. Therefore, the two triangles will be similar by SAS similarity criterion. Side, angle, side, angle, side proportionality theorem. Hence proved. Question number 15. A vertical pole of length 6 meter cast a shadow 4 meter long on the ground and at the same time a tower cast a shadow of 28 meters long. Find the height of the tower. You can see that CD is a pole and AB is the tower, right? It is given that the height of the pole is 6 meter and cast a shadow of 4 meter. And at the same time, we have got a tower and this tower is casting a shadow here at the same time and the length of the shadow is measured to be 28 meters, right? We are supposed to find out the height of the tower. How do I do it? Now, we know one thing. If the shadow is cast at the same time, the angle which the sun forms with the pole as well as the tower will be the same. That means these angle F and E should be equal, right? Now, if you consider the triangle ABE and CDF, what do you know? The two angles, which is angle subtended by the sun to the ground, will be equal. And CD and AB are vertical towers. So each of the angles will be right angles. So that means that triangle ABE and triangle CDF will be similar to each other. And if the two triangles are similar, we know that the sides will be proportionate. So AB by CD is equal to, that is BE by FD. Now substitute the value. We know that AB is to be calculated, which we are taking as H. Instead of CD, write 6, and instead of EB, write 28, and FD, you write it as 4. Cross multiply, calculate, you will get the height of the tower will be equal to 42 meters, right? Question number 16. If AD and PM are medians of triangle ABC and PQR respectively, where we are given that, question number 16, AD and PM are given as the medians of triangle ABC and PQR respectively, where triangle ABC and PQ are similar to each other. We are supposed to prove that AB by PQ is equal to AD by PM, right? How do we do it? Let us first consider triangle ABC and PQR. We know that in two similar triangles, the sides are proportionate, right? So we will have this AB by PQ will be equal to BC by QR, and that is also equal to AC by PM. Also, we will have the angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R, right? Okay. Now, what is BD now? Since AD is the median, we will have BD as BC by 2. And what about QM? QM is equal to half of QR, that is QR by 2. Now, we already in the equation 1, we have got AB by PQ is equal to BC by QR, and that is equal to AC by PR. Now, instead of BC by QR, put half of BC and half of QR. Now, what is half of BC? Instead of that, we can write it as BD and QM, right? So, if you consider triangle ABD and triangle PQM, you have angle B is equal to angle Q. And also you have got this AB by PQ is equal to BD by QM. So, the triangles ABD and triangle PQM are similar by SAS similarity criterion. SAS, right? Now, that will make AB by PQ is equal to AD by PM, because in similar triangles, the sides are proportional. Hence proved.